Também, também. Bom dia, bom dia.
Good morning, everyone. I hope you're all good. I hope you guys are well rested yesterday. Today, we're going to start with the LP7. Brandon is sharing the screen. Can you guys see it?
Yes, I can see it.
Thanks, Taryn. Thanks, guys. So let's start off with the first question, and then yeah, we'll get going. Okay, guys, starting with the first question, explain the difference between a standalone computer and a network computer. So, anyone wants to give it a try? Okay, Taryn.
To my understanding, a standalone computer is not connected to any other PC or something in a network or whatever, and then a network computer is connected to more than one device yeah.
Thank you, Taryn. Um, that was profound. Okay, anyone else wants to give it a go? Different answers? Anyone? Going once, going twice? Okay, no one. So I guess these are like simple questions. So we'll just have like one person per question and maybe two people. So I think we should move on to the next one.
Paul, can you just give me like a minute because I want to open my answers and stuff as well on the side. So just give me a minute before we move on.
Okay, cool. I'm also trying to open mine so I can share what I have from my side. Yes, too. I see you wanted to say something there.
Nah, not really, G.
Oh, wait, no stress,
Oh,
no stress.
yeah.
Okay, on my side, I can add something while Brandon is looking for his. I have a standalone computer operates independently and is not connected to any other computer or network. Okay, it is used for individual tasks like word processing, gaming, or personal projects. And then for networked computer, I have a network computer is connected to other computers and devices, often through a local network, a LAN, or internet, commonly used in workplaces, schools, for collaborative tasks, live sharing, and accessing centralized resources. So I just gave 2 points for my one there. Brandon, whenever you're ready, you can share your answer.
I wasn't gonna share my answer for that question. I was just like trying to get my
Okay,
stuff
cool.
open, but it's quite similar. It's quite similar to you guys's. But if you
Yeah.
want to move on, we can.
Yeah, it's very basic. So let's move on to the next one. Next question.
Oh, hold on.
Okay, the next one, describe mid-range computers or mid-range systems and client-server model. Anyone wants to give this one a go?
I can go with this one.
Okay.
Okay, in terms of mid-range computers, These are often referred to as mid-range systems. They are a class of computing systems that fall between mainframe computers and personal computers in terms of size, processing power, and cost. They're designed to handle moderate level of workloads and are commonly used by a small to medium-sized business. Some of the key characteristics include, in terms of processing power, they are capable of supporting multiple users and running various applications simultaneously. They often have multi-core processors and sufficient memory to handle business applications. These systems can be easily upgraded or expanded to accommodate growing business needs, such as adding more users or applications. In terms of the reliability, they are designed for high availability and reliability, often featuring redundancy in hardware components to minimize downtime. And then in terms of the cost effectiveness, they provide a balance of performance and cost, making them an attractive option for organizations that require more power than personal computers, but do not necessarily need the extensive capabilities of mainframes. Then move on to the client-server model. The client-server model is a network architecture that divides tasks between service providers, which are the servers, and the service requesters, which are the clients. So in this model, the clients are the devices that are, or the devices or applications that request services or resources from the server. Clients can be desktops, laptops, or mobile devices running client software to access server resources. Then in terms of the servers, these are powerful computers or applications that provide resources, services, or data to clients over a network. They manage tasks such as data storage, processing requests, and running applications. Then in terms of the communication, the client-server model relies on a network to facilitate communication between clients and servers. Clients send requests to servers, which process these requests and return the necessary information or services. And lastly, centralization. This model allows for centralized management of resources and applications, making maintenance, updates, and security quite easier to manage. Yeah, that's all I have, Chief.
Sheesh, you just overly exhausted that one, man. Nice one. Thanks, Isetu. Um, so we can move on to the next question. Thanks, Brandon. Give a description of the characteristics of the configurations. Anyone else there wants to give this one a go?
I don't really understand this question, if I'm being honest.
What did you say, Terrence? Sorry, I couldn't hear you there. You don't understand this one.
Yeah, I don't really understand the way they worded it. I don't understand like how to answer it.
The tricky one. Hey, okay, let me check what I have on my side. Brandon, did you want to say something there?
No, I was basically going to second what she said. It's one of those questions that I kind of have like red marked on my side because I'm uncertain myself. So, yeah.
Yeah, it's a tricky one. I think we should also ask Miss Linda when she comes back.
I think Mr. X is the one to ask, really.
Yeah. Okay, cool. So, do you guys have anything under this yet, or did you guys just leave it blank for now?
Can I share my part?
Okay, cool. Samkele, let's go for it.
Okay, I have single user, single task, right?
Yeah.
This configuration describes a very basic computer setup where only one user can interact with the system at a time, and only one program can be executed at a time. These systems were common in the early days of computing and are now primarily found in specialized applications. These systems often have very basic operating system designed to manage a single task at a time. The computer may have limited memory and processing power as it is designed for basic tasks. And then I have a single user multitask. This configuration refers to the system where one user can execute multiple programs concurrently. This is achieved through the oper- time sharing the operating system, rapidly switching between different programs, giving each a small slice of processing time. This creates an illusion that all programs are running simultaneously, even though they are sharing the CPU resources. Only one user can access and interact with the system at a time. The operating system manages the allocation of CPU time of different programs, ensuring each gets a fair share of processing power. Yeah, that's all I have.
Nice, Samkele. You basically have a similar answer as I here, but I first wrote the description of computer configuration, and then I wrote a multi-user system and the single user and the multi-user. So it's kind of basically the same as yours. So I don't know if the others have a similar context to yours or what.
They say it looks like he has something different. The man is stroking his chin there.
Yeah. He's thinking twice there. Tell us what you have there, Setu.
Yeah, it was completely different from the way he started it, but as he went along, I kind of had similar stuff as well. So I can just read out my response.
Okay, cool, cool. That would be nice,
Okay,
man.
when discussing configurations, particularly in the context of computing systems, several characteristics are noteworthy. Then I have on the first one, it's the hardware specifications. This includes the processor type, amount of RAM, storage capacity, and peripheral devices. Higher specifications typically indicate better performance and capability to handle complex tasks. Number two, I have software compatibility. Configurations must support the required operating systems and applications. Um, Compatibility ensures that the hardware can effectively run necessary software without issues. Thirdly, I have network capabilities. This refers to the ability of configurations to connect and communicate over networks. It includes support and wireless connections, such as protocols for data transfer. Fourthly, I have uh, accessibility. Configurations should be designed with user friendliness in mind, ensuring that users can easily interact with the system and access necessary resources. Then lastly, I have scalability and upgradability. Configurations should allow for future upgrades or expansions to accommodate growing needs without requiring complete system replacements. So it's somewhat similar, but yeah, not really.
Mm, mm. I see you went super in detail there, hey? Because I feel like our answer is just like on the board, just like a overview of what it is. But your,
Surface level.
huh?
I hear you.
Yeah. I feel like you went straight into detail there. But yeah, it sounds about right though. We'll just get like for us, Miss Linda, to Mr. X there to check it out for us, whether they need to change that question or what.
I will compile a list of the questions that we are like kind of struggling with, and then I will send it to him.
Okay.
Hopefully he gets back to us. If not before Friday, then on Friday. So yeah.
Cool. Thanks, Brandon. Thanks. Well appreciated. Um, So, okay, let's move on to the next one. Is this one the next one, Brandon? Oh, okay. Thanks. Okay, the next one, demonstrate an understanding of the environment requirements of the configuration. Anyone wants to give this one? Females?
For this one, I basically left it open as well due to the previous question. So it's one of you guys will have to like hop in here.
Okay, cool. It's because it's kind of linked. It's like a linked question. Okay, let me see what I have on my side. SAT, do you want to give it a try there?
Yeah, understanding the environmental requirements of configurations is crucial for optimal performance and overall longevity. So these are some of the key considerations to include. Number one, it's physical space. Adequate space must be provided for hardware installations, including room for air circulation and maintenance access. Overcrowding can lead to overheating or physical damage of the components. And number two, I have temperature and humidity control. Computing systems require a stable environment, typically between 20 degrees to 25 degrees Celsius, with low humidity levels. Extreme temperatures or high humidity can damage hardware components. And thirdly, I have power supply. Reliable and sufficient power supply, it's essential for configurations. Considerations include the need for uninterruptible power supplies, which is the UPS, to protect against power failures and fluctuation. And fourthly, I have ventilation. Proper ventilation is necessary to dissipate heat generated by hardware. Systems should be placed in environments with adequate airflow to prevent overheating. Then lastly, I have security measures. Environmental considerations also include physical security to protect hardware from theft, damage, or unauthorized access. This might involve secure access controls, surveillance, as well as protective enclosures. Yeah, that's all I have there.
Thanks, SAT. Thanks. Sheesh, that's an intense answer you got there, hey? I got something different, but it's like an overview of what you have. I can just give it so to see if someone else has something similar to SATs or mine. So I said when developing an application, you often need to run your code in various environments such as development, staging, or testing, and production. If each team member develops on their own machine, they may need different environment requirements. And then the next point I wrote, each environment will have a unique set of properties, including data source details, file paths, a domain name, some configuration properties like company name or application constants should remain consistent across all environments. And then my examples here, I have asset path, document path, data source name, data source user, data source password, and then assets URL, documents URL, company name again. So yeah, that's what I have. It's kind of different. Anyone else wants to add? Okay, no one going once, going twice.
I think our answers are similar to yours in SE2.
Or they similar, eh?
Yes, because they just include the temperature control, also include space, also that I have for data storage. I don't think you guys have data storage. So my data storage, it says consider the amount of data you need to store and choose a storage solution such as hard drive, solid state drive, cloud storage that meets your requirements. Yeah. So everything else is the same basically.
Oh, thanks, Kelly. Yeah, thanks. I think we can move on to the next one. Brandon, do you think we should also mark this question as a to be checked on?
Question the one you just answered.
Yeah.
Yeah, I already have it marked down as one of the questions. Yeah.
Okay, cool, cool. Because we don't know who else is struggling with it. So, yeah. Okay, moving on to the next one. Describe categories of computer system applications. Let's go, guys.
I'll take a shot at this one.
Thanks, Brandon.
Okay, so firstly, I have embedded systems. This is when information like names and addresses is stored on a mobile device or a digital diary. A small program embedded in a chip within the device handles those tasks. This type of system is known as an embedded system. This can be your BIOS and stuff like that. Next, I have Windows applications. Windows applications are form-based programs that run on the Windows operating system. Examples include Microsoft Word and Paint, which are also referred to as desktop applications. Next, I have web applications. This is a website application, also well, a website also known as an application. Web application is a collection of web pages hosted on a special computer called a web server. This server can be located anywhere, and users can access the site from any location via a web browser such as Internet Explorer or Mozilla Firefox. Then next I have web services. Web services are web-based applications that provide services to other applications through the internet. For example, search engines like Google and Yahoo allow other applications to use their search functionality over the internet. Then lastly, I have console applications. Console applications run within the command prompt, such as the DOS window. These are lightweight programs often used for testing purposes. That's about all I have.
Thanks, Brandon. Profound. Anyway, I also have the same answer as yours. The everything you mentioned, I have the same as yours. It's just written in different ways here, but it's similar. I think we can move on to the next one. Guys, can I just get a quick 2 minutes? I just need to do something quick. I'll be back right now. Just a quick 2 minutes.
I can take over on my side, Paul, if that's okay, so that we can keep things moving until
Yeah,
you get
yeah,
back.
yeah, yeah.
Until
Yeah,
you get back here.
yeah, you can carry on with this question so long, and then I'll be back by the time you finish.
Okay, cool.
Thanks, Brandon.
Okay, guys, so the next question is define batch processing. If anyone wants to have a go at it, please go ahead. And if not, I will go ahead. Just, yeah.
Yeah, I'll go. Am I
Okay.
audible?
Yeah, Tapelo, you may go ahead.
Okay, batch processing is a method of executing a series of tasks or jobs without manual intervention. It's typically used when a large volume of data or processes needs to be handled efficiently and real-time interaction isn't necessary. In batch processing, tasks are collected over a period of time, then processed all at once. This contrasts with real-time processing, where tasks are handled immediately as they occur. Batch processing is ideal for tasks that are repetitive and can be executed during off-peak hours to optimize system resources. It's pretty long, but I'll just give that the summary of it.
Yeah, so if anyone doesn't like has anything they want to add or what, then they can, but if they feel the answer is similar, then we can move on and Paul can take over again.
Okay, cool, guys. I also have the similar answer. Okay, next question is define interactive processing. Easy, guys, easy. Let's get more people.
I will go with this one. It is a short answer.
Cool.
Interactive processing refers to a data processing approach where users directly interact with the system and receive immediate responses to their prompts, to their inputs, sorry. This real-time processing allows for immediate feedback and interaction, making it ideal for applications that require instant results, such as online banking, data entry systems, video games, and word processors. The key benefit of interactive processing is its ability to provide immediate responses to user actions, enabling dynamic and responsive interaction with the system. That's my answer.
Nice, Brandon. We kind of have a similar answer as yours. I see Tapelo's hand is up. Go for it, Tapelo.
Okay. Interactive processing is a method where tasks are executed immediately based on user input or requests, allowing real-time interaction between the user and the system. Unlike batch processing, where jobs are queued and processed in bulk, interactive processing responds to commands instantly, making it ideal for applications that require immediate feedback such as word processors, web browsers, and database queries. Users can input data or make requests and the system processes them on the spot, displaying, displaying results almost instantaneously. One of one of the key advantages of interactive processing is its responsiveness. Users receive immediate feedback, allowing them to correct mistakes or adjust their actions in real time. This is crucial in environments where quick decision making is essential, such as customer service platforms, video gaming, and online transaction systems. The real-time interaction creates a more dynamic and user-friendly experience.
Thanks, Tapelo. Same. There's like a profound answer there. Okay, let's move on to the next one. Unit Standard 2. Okay, Unit Standard 2, Session 1. Define computer architecture. Anyone wants to give it a go? Females, where are we? Zamasa. Thank you, Zamasa. Please go for it.
Right, I said computer architecture refers to the design and organization of a computer's internal components, including the central processing unit, CPU, memory, input or output, devices, and other supporting systems. It defines how these components interact and process data, and it plays a crucial role in determining the overall performance, power consumption, and functionality of the computer. And then I said computer architecture encompasses instruction set architecture, which is ISA, the large language of instructions that the CPU understands, microarchitecture, the design of the CPU, including number of cores, threads, and execution units. And then thirdly, I said system architecture, the organization of the computer's internal components, including the CPU, memory, and output or input devices, memory hierarchy, the organization and management of memory, including caching, virtual memory, and main memory. Thank you.
Oh, thanks, Amasa. That is like 100% right there. You got it like all the way. I got a similar answer. If anyone has something different, you can add, um, or we can move on to the next one. But it's straightforward, guys. So maybe we should move on to the next one, which goes into detail. Okay, next question. Identify functions of elements which make up a computer architecture.
Can I go?
Yes, you can go.
Okay, I said the elements that make up computer architecture are number one, control unit, which is CU. It retrieves instructions, decodes them, and executes them. Number two is arithmetic logic unit, ALU. It performs arithmetic and logical operations. Thirdly, I said registers, small amount of on-chip memory that stores data temporarily. Fourthly, I said bus. I don't know if that's how it's pronounced. Communication pathway. It does the communication pathway for data transfer between components. And then on the fifth one I said memory, which is RAM. It stores data and programs instruction. On the sixth one I've got input or output devices. They allow interaction with the outside world, e.g. keyboard and display. On number seven, I've got clock. It generates a clock signal to synchronize components operations. Lastly, I've got instruction decoder. It translates instructions into control signals. Thank you.
Thank you. Well appreciated. That was good. Another 100% for you. And is there anyone else that wants to add on to that answer? If you have like 1 or 2 points different, then you can just give it out.
Did she have bus?
Yeah, she had bus.
She had system clock also,
Yes.
and then input output devices.
Yes, I did.
Yes.
Okay. I think everything is the same then.
Yeah, I think we can move on.
Yeah.
Okay, cool. Thanks, Kelly. Thanks, guys. Next question. Okay, next question. What is the idea of software simulation? Discuss the advantages and disadvantages. Easy one, guys. Who wants to give this one? Who wants 100 here? Tapelo the man. Let's go.
So software, I'll start by defining it as the question says. Software simulation refers to the use of a computer program to replicate the operations of real-world systems, processes, or environments. By creating virtual models, simulations enable users to explore how these systems function under different conditions without directly interacting with the actual physical system. This method is widely employed in sectors such as engineering, education, healthcare, and research to test theories, providing training and enhance system designs before implementing them in the real world. Now I have the advantages of software simulation. Number one, it's cost efficiency. Simulations significantly reduce experiences by negating the need for physical prototypes, which can be costly and time consuming to create. Number two, risk mitigation. By conducting experiments in virtual setting, simulations eliminate the inherent risk of real-world testing. Number three, adaptability and precision. Software simulations offer the ability to easily adjust parameters and conditions, allowing for detailed exploration in various scenarios. Number four, efficiency in time. Simulations often provide results far quicker than real-world testing. And then I have the disadvantages. The first one is limitations in accuracy. The reliability of a simulation is dependent on the quality of the model and the accuracy of the input data. Simplified models or incomplete data set can lead to misleading outcomes which may not accurately reflect the real-world behavior. Number two, high computational demands. Simulating complex systems, especially those with a large number of variables, requires significant computational resources. This often necessitates access to powerful hardware and specialized software. Number three, omission of real-world variables. Certain factors in real-world scenarios, such as unpredictable environmental conditions or human error, are difficult to incorporate in a simulation. And the last one, overdependence on simulations. Relying exclusively on simulations without supplementing them with the real-world experiments can lead to misguided conclusions.
Thanks a lot, Tapelo. Just got yourself 100 there. I think we can move on because with the disadvantages and advantages, we're mostly gonna have similar answers, maybe one or two different, but yeah, we can move on to the next one. Okay, next question. What type of binding occur at language definition, language implementation, at translation, and execution? For 6 marks, who's gonna take that for us?
Can I attempt this one? Samasa, is that okay with you?
No, yes, it's fine, Brendan. You can
Okay.
go.
Okay, so Martha, you can take the next one then.
Yeah, so firstly, it's sorry, it's language definition. At this stage, binding involves defining the rules and mechanisms for associating identifiers with their properties. So within language definition, you have syntax binding. This determines how language constructs are structured and how identifiers are used, such as how variables are declared and used. Then you also have semantic binding. This specifies the meaning of language constructs, like what an integer literal represents and how type checking is done. Next, we have language implementation. During implementation, binding refers to how the compiler or interpreter internally represents language constructs. Within language implementation, you have type binding. This associates data types with variables and functions, defining how different types are represented and manipulated in memory. You also have storage binding, and this involves allocating memory for variables and functions, including managing their lifetime and where they are stored, for example, a stack or a heap. Next, we have translation, if I'm not mistaken. In the translation stage, which includes compilation and interpretation, binding involves converting language constructs into machine code or intermediate forms. Within translation, you have static binding. This occurs at compile time where types and other attributes are determined and checked and seen in statically typed languages. You also have dynamic binding. This happens at runtime, often related to polymorphism and dynamic method dispatch. For example, the method to be executed is determined based on the type of the object during a runtime. Then lastly, we have execution. During execution, binding involves the actual allocation of resources and the resolution of identifiers as the program runs. Within execution, you have variable binding. This associates variable names with specific memory locations where values are stored. You also have function binding. This links function calls to the actual implementations with dynamic language resolving these calls at the runtime. And then lastly, you have address binding. These are maps. This maps logical addresses used in the program to physical memory addresses either at compile time, which is static, or runtime, which is dynamic. That's the last thing I have.
Wow, Brandon, you exhausted that question. It's tired. Nice one, man. Profound, profound. Let's move on to the next one. I also have a similar answer to your one. So, yeah, profound. Okay, next one, guys. For 15 marks, briefly describe and explain the purpose of computer components. Samasa, are you still up for that?
Yes, I can do it.
Oh, thanks.
It's a lot, man. Can't you do it?
SAT likes the long answers, so maybe we should give it to
He
him.
can go, yeah. He
Give
can
us
go
a
for it.
paragraph there, SAT. Give us an essay there. Okay, Tapelo is up for it.
I don't think it's much of an essay, but yeah, okay. Okay, on number one, I have the CPU, Central Processing Unit. The CPU is the brain of the computer, mainly responsible for executing instructions from the programs. It performs arithmetic and logical operations, processes data, and manages the flow of information within the system. Number two, I have memory, which is the RAM. Random access memory temporarily stores data and programs that the CPU is currently using. It provides fast access to data, allowing for efficient processing. When the power is turned off, data in RAM rather is lost. Thirdly, I have the storage, which could be either the hard drive or SSD. Storage devices like hard drives or solid-state drives are used to permanently store data and programs. Unlike the RAM, data remains intact even when the power is turned off. Storage is crucial for long-term data retention. Next, I have motherboard. The motherboard is the main circuit board that connects all the components of the computer, including the CPU, memory, storage, and peripheral devices. It facilitates communication between these components through buses and connectors. Next, I have power supply units, the PSU. The power supply unit converts electrical energy from an outlet into usable power for the computer's components. It ensures that each part receives the appropriate voltage and current. And next I have input devices. Input devices such as keyboards and mice allow users to interact with the computer. They enable the input of commands and data for processing. And next I have output devices. Output devices such as monitors and printers display or produce the results of the computer's processing. They convert the digital information into formats that users can understand. The next I have graphics processing units, which is basically the last one. The GPU is specialized hardware designed to accelerate the rendering of images and video. It offloads graphics processing tasks from the CPU, improving performance in graphics intensive applications such as games and design software.
Nice, Setu.
Yeah,
Nice. That is competent.
Uh, um,
Is
sorry,
it
Esetu, did you have a cooling system?
it's missing some stuff. Yeah,
And that I have that one, and I also have the case itself. So I just add those
yeah. We can just add those.
yeah, you can add it up.
because everything else is similar. So with cooling system, this includes your fans and heat sinks to remove heat generated by the CPU, GPU, and other components, helping to prevent overheating and to maintain performance. And then lastly, I have the case itself. This encloses and houses and protects all the internal components in your computer. Yeah, that's basically all.
Thanks, Brandon.
Okay, guys, is it just me or this module is way too short?
Yeah, it's
It just
short,
got
hey?
9 pages on my side.
Yeah, it's very short, yeah.
Yeah,
Let's put it that way.
especially the summative.
Ah, wait.
Yeah, so it said to Brandon, so how many points did you guys put for that previous question there? Did you put like 15 or did you put 10? How many?
I
I've
have
got
9 on
8.
my side.
Sorry?
I've got 8.
I
Oh,
have I have 9 on my side. I think it's you are listing and
Just
then
the
also
pen.
defining. Like sometimes that counts for 2 marks.
It's 2 marks
Yeah,
for each.
yeah,
Yeah.
yeah. I also have 9 on my side.
okay, cool, guys. Cool. Nice,
Paul,
nice.
I moved on to the next question. But can I just be excused for like 2 minutes? You guys can continue with this question though. Hopefully, I'll be back before you're done.
Okay, cool, no stress. You can do that, Brandon. Okay, next question. Okay, next question. Demonstrate understanding of classification of instruction sets for 5 marks. Easy peasy. Who's taking this one? Tapela, I saw your hands was up for the previous one. Do you wanna give this one a shot?
Definitely not me.
I'll be giving.
No pressure.
So instruction sets or instruction set architectures refers to the collection of machine level commands that a CPU can execute. These sets define the operations the these sets define the operations the processor can perform, such as arithmetic, data transfer, or control flow. Instruction sets can be classified based on various criteria such as complexity, functionality, and the number of operands they support. Uh, and then next I have one of the most fundamental classifications of instruction sets is into complex instruction set computing, or CISC, and reduced instruction set computing, also known as RISC. CISC architectures feature a large number of complex instructions, some of which perform multiple low-level operations. For example, memory access and arithmetic in a single command. This design aims to reduce the number of instructions required to perform a task, theoretically making the code shorter. Theoretically making the code shorter. However, CISC instructions are more complex to decode and execute, which can lead to inefficiencies in modern pipeline processors. In contrast, RISC architectures employ a smaller set of simpler instructions that can execute a single clock cycle. The philosophy behind RISC is to simplify hardware by limiting the instruction set, which allows for a faster instruction decoding and higher clock speeds. RISC processors rely on software to handle complex tasks through multiple simple instructions, thereby reducing the complexity of the hardware at the expense of potentially increasing the number of instructions executed.
Thanks, Tapelo. Thank you. I kind of have similar answers to yours, and yeah, I don't know. Does anyone have anything to add? I can add like just the points of extra stuff I have on my side in case you guys also have it. There's also a minimal instruction set computer, and then the other one I have is one instruction set computer and very low instruction word computer, which is VLIW. So yeah, those are the extras I have on my side. So if you guys have something similar, don't be scared. We're all on the right track. Okay, moving on to the next question. Brandon, are we back? Cool. Thanks, Brandon. Okay, identify examples of operations common to many instruction sets for 7 marks. Who's taking this one? Tapelo. Oh.
Tapelo, do you want to go with this one? Because it is also quite long.
So I don't know if it's from the previous question.
Yeah,
or...
I can give it a go.
Brandon,
yeah, I'm listening.
do you use the learner guide?
I still do like both. Like, so if the learner guide doesn't have what I'm looking for, like if I feel the learner guide is like on some like BS, then I use the internet.
That was clever there, Lord. Yeah. Tapelo, go ahead, man.
Okay. The characteristics I have number one, extensive instruction set, and this does not refer to the extensive word, but CISC architectures are characterized by a vast and heterogeneous array of instructions, enabling the execution of complex operations with minimal lines of code. This extensive set includes specialized command for tasks such as string processing, integrate arithmetic, and data manipulation, thereby allowing a single instruction to encapsulate multiple operations. Number 12, variable length instructions. In contrast to RISC architectures, which employ fixed length instructions, CISC architectures utilize variable length instruction formats. This flexibility facilitates the representation of a diverse range of operations, allowing simpler instructions to occupy less space while accommodating more complex commands within longer instruction formats. Number three, I have sophisticated addressing modes. CISC architectures typically support a multitude of addressing modes, permitting nuanced data assets methodologies. These modes encompass direct and indirect, indexed and register relative addressing, thereby simplifying the retrieval and manipulation of data structures, particularly in high-level programming. And then I have number four, it's microcode implementation. Many CISC architectures employ microcode to realize their extensive instruction sets. This technique involves a layer of low-level instructions that translate high-level commands into simple machine-level operations. While microcoding allows for remarkable flexibility and extensibility, In instruction execution, it may introduce additional overhead and complexity. Number 5, integrated memory operations. CISC instructions often amalgamate multiple operations such as fetching data from memory and performing computations on it within a single instruction.
Yeah.
This capability significantly reduces the number of discrete instructions required for a given task, thereby minimizing the need for intermediary storage and enhancing operational efficiency. Now, number 6, higher instruction density. Program developed for CISC architectures typically exhibit a lower instruction count relative to those written for RISC systems. And the last one, comprehensive control flow support. CISC architectures provide a robust support for control flow operations such as conditional branches, jumps, and subroutine calls. These instructions enable modifications to execute for the execution path based on specific conditions, facilitating the construction of complex programmatic structures without necessitating an extensive array of discrete functions.
Hey, Otapelo,
Sure.
which question were you responding to? The next one or number 7?
I was responding. Oh, my bad. I was responding to.
The next one, ne?
Oh, I skipped the question.
Yeah. I figured it was like, hey.
Yeah, it looks like he had a close answer for the next one there. So, Brandon, I see your hand is up there. Do you want to give this one a go then?
Yeah, and it is because he, answered the next one.
Yeah.
So this one was now technically incorrect because he answered the wrong question. But
Yeah.
just the pillow for like the purpose of the next question, like mine is the same as his for the next question as well. So we might as well skip that one.
Okay, cool.
But I will answer this one since I am already here.
Cool. Thanks.
So firstly, the operations that I have is data handling and memory operations. And then within these instruction sets, you can assign, or like some of them are like you can assign a fixed value to a register. Another instruction is transfer data between a memory location and a register, either for storing results or retrieving data for future computations. And then I also have read and write data from hardware devices. Then the next operation set I have is arithmetic and logic operations. This is to perform basic arithmetic operations like addition, subtraction, multiplication, or division between two registers, storing the result in a register, and possibly updating condition codes in a status register. It is also used to execute bitwise operations such as perform logical and or between the bits of two registers or negating the bits in a register. That sentence was a mess. And then I also have compare the values in two registers, for example, to check if one value is less than the other or if they are equal. The next operation that I have is control flow operations. Some of the instructions here, instruction sets here are to jump to a different part of the program and execute instructions. It is also used to conditionally jump based on whether a certain condition is met. And lastly, indirectly jump to a location while saving the current location for later return. Then the next operation set I have is the shift and rotate operations. Shift bits in a register to the left or right, filling the vacant bit position with zeros or the original sign bit. None of this makes sense to me. Rotate bits within a register either left or right, wrapping the bits around to the other end of the register. The next operations I have is the floating point operations. This is to perform arithmetic operations like addition, subtraction, multiplication, division on floating point numbers stored in the registers, and also to convert between integers and floating point values. Then the next one I have is string operations. This is to perform operations on strings or sequences of bytes, such as copying, comparing, or searching for a specific value within a string. Next, I have stack operations. This is to push data onto the stack or pop data from the stack, and also to perform operations related to function call management, such as storing the return address when calling a function or retrieving it upon return. Next, I have system control operations. This is to perform privileged operations that control or configure system settings, like modifying process status or setting system level registers. And then, is this my last one? No, second last one. I have synchronization operations. This is to perform atomic operations for managing access to shared resources, such as acquiring or releasing locks in a multi-threaded environment. And then lastly, I have vector or SIMD, which stands for single instruction multiple data operations. This is to perform operations on multiple data points simultaneously, such as adding or multiplying multiple values in a vector or array in parallel. None of that makes sense to me, so it just feels wrong. I want to hear what you guys have to say about that one.
Well, I have similar answers on my side.
Okay, thank God.
Yeah, I don't know. Does anyone else have something different to add there?
Are we on question 7?
Yeah.
Oh, okay. Hey, I was afraid. Hey, hey, hey. Yeah. Okay, I think, yeah, everything is similar. It's just that yours is in more details because you have arithmetic and
details.
logic, right?
Yeah,
Yeah.
Brandon is also going deep into detail, like I said to you, there's some paragraphs.
Yeah.
Yeah, you went even deeper than me on that one, bro. Imagine.
Yeah.
Hey.
I never thought it was possible.
As Ma'am
Yeah.
Linda says,
Yeah.
profound, profound. Okay, let's move on, guys. Let's move on there, Brandon, on the screen. So I guess we're gonna skip that other one because Tapelo killed it. He's moving forward straight to the future. Like I just wanna finish this, man. So yeah, let's move on to the next question. Oh, this is the next question, right? Describe the design constraints in the design of instruction sets for computers with reference to instruction length. Anyone wants to give this one a go? 5 marks. I see someone's hand is up, but I can't see whose hand it is.
I'll take a shot at this one if that's fine.
Okay, cool, Brandon, go for it.
Yeah, so so fixed length, and then I also have variable length. So yeah, fixed length instructions are easier to decode and pipeline because the CPU knows exactly where the next instruction starts. However, they can be inefficient because some instructions may not need the full length, wasting which could waste memory. And then I have variable length instructions. This provides more flexibility and can save memory space by using shorter instructions for simpler operations. However, decoding is more complex and slower since the CPU must determine where each instruction ends. And the impact on performance, longer instructions can handle more complex operations but may slow down execution speed due to increased memory access times, while shorter instructions execute faster but may require more instructions to perform the same task. My answer is very short there. I feel like I'm missing some stuff.
Um, I have the same kind of answer as yours, but yeah,
If
I mean,
I wait, if I can expand on mine, I also in like other than that thing about the length, the instruction length, let me just
yeah,
check something. I also went into detail more about the instructions sets, like in terms of classification and stuff like that. Um, but because I felt like my answer was too short. But
yeah.
if anyone has anything else concerning the instruction length thing, like if they want to add something like that would be really helpful right now, because I feel like I need to expand on my answer.
Um, on my side, I have complexity of instructions. Longer instructions can encapsulate more operations, operands, and addressing modes. However, this can lead to increased complexity in coding, in decoding logic, and slower execution times, and different instructions may require different amounts of time to decode. And then I have memory efficiency. Instruction length affects how many instructions can fit into memory. And then I also have performance trade-off. The design must be able, no, the design must balance between the richness of instruction sets and execution efficiency, while no longer instructions No, while longer instructions may simplify certain tasks, they can increase the number of cycles needed for the execution, this impacting overall performance. The classic performance equation, um, execution time equals to cycle per instruction time times cycle time. That's like the formula. Emphasizes this trade-off. And then the last one is impact on compiler design. The choice of instruction length influences how compilers generate codes. With variable length instructions, compilers must implement more complex logic to determine how to encode operations efficiently, which can increase compilation time and complexity. So yeah, those are the ones I have on my side, Brandon.
Okay, cool, man. I feel like with the first half of your answer, like mine is just worded differently, but I
And
will
the
I will
same.
adjust my answer to like include some of your other points because I feel like that's what I was missing. So thanks for that.
Cool, man. I think we can move on to the next question. If I'm not mistaken, it should be Unit Standard 3, the last unit standard.
Hey, this is short, hey?
Yeah, it's
We
very
already
short,
on
Samket.
unit 3.
Very short. It's better than that mathematical one. Okay, let's get to it. What is involved in a hardware test program? No mark allocation, so I don't know how much that one is out of.
Yeah, let me give it a go.
Cool.
So, uh, what is involved in that's the question, right?
Mm, yes,
Yeah.
yeah.
Okay, I have key elements here that are involved in hardware testing program. So number one is the test planning. This initial phase includes defining the scope of testing, identifying hardware components to be tested, for example, CPUs, memories, or storage devices, and establishing criteria for success. It may involve developing a comprehensive test strategy that outlines objectives, resources, timelines, and required tools. Number two, I have Test environment setup. Creating a controlled environment for testing is essential. This includes configuring the necessary hardware and software such as test benches, operating systems, and any simulation tools. The setup must ensure consistency and minimize external factors that could influence test results. Number 3, I have test case development. Test cases are designed to evaluate specific functionalities and performance metrics of the hardware. This involves writing detailed scripts or programs that execute various operations such as stress testing, performance benchmarking, and functionality checks. Each test case should specify the expected outcomes and condition for success. Number 4, execution of test. During this phase, the test program is executed according to the predefined test cases. This may include running tests, functional tests, and reliability assessments to gauge how the hardware performs under different conditions. Data is then now collected during this process for analysis. And then I have number 5, result analysis and reporting. After executing the tests, the results are analyzed to identify discrepancies between expected and the actual performance. This analysis helps in diagnosing potential issues or failures. The findings are typically documented in a report that summarizes the methodology's outcomes and any recommendations for improvements or further action. I have number 6, debugging and validation. If any issues are identified, debugging procedures are initiated to isolate the causes of failure. This may involve rerunning tests, adjusting configurations, or using diagnostic tools. Validation ensures that the hardware meets the necessary specifications and performs reliably under expected workloads. And then the last one, following any changes or repairs, regression testing is performed to confirm that modifications do not introduce new issues. This step is crucial in maintaining the integrity of the hardware after adjustments have been made.
Thanks a lot, Tapelo. Anyone else has something different to add there, you're welcome to add. Or if you have a different answer, we should know of. I think we're good, huh? Okay, next question. What is involved in a software test program? Who's giving this one a go? Anyone? Come on, guys. We are class
Just
of.
give us your answer, Paul. They're not
Give
gonna
us
answer.
your answer, man.
Come on, guys. We are class of 60. Let's go, guys. Let's learn to participate. Ladies, come. Okay, let me check what I have. Okay, what is involved in software testing program? The first one I have is design reviews. This includes two primary reviews, the primary preliminary design review, which occurs after high-level design documents are completed, and the detailed design review, which follows the submission of more detailed documentation. The next one, development testing. This phase encompasses various testing types, including prototype test, pre-testing, unit testing, and software build integration testing, typically conducted off the software developer's facility. And then the last one I have site testing. Site testing consists of hardware, software integration testing, subsystems testing, and system testing. While some integration testing can take place in a development environment which represent hardware, final testing must occur off the installation site, ensuring proper communication with field devices. Okay, that's what I have for that question. I don't know if anyone has something different to add on. Okay, that was a profound answer. Let's move on to the next one.
I saw Ivana's
You're
hand.
not saying
Ivana.
Ivana, thanks, Ivana. Pull up.
Yeah. So basically, I don't know if what you and I have is the same, but like to summarize what is involved in a hardware test program is your prototype testing, and then your design approval testing, your factory acceptance testing, site testing, burn-in observation period testing, as well as final acceptance testing. So I'm not quite sure. I just wanted to know if you could please repeat your answer just to see if there's like a similarity between you and me. My answer and your answer actually.
Site testing I have, which you have, and then I have development testing, then I have design reviews testing. Those are the ones I have. I put 3 points there, so um,
Okay. Thank you. I'll just have a double check.
yeah,
And
but
Brandon, what did you put down?
it sounds about the same though. It's just
Yeah, mine is quite similar. It's the design, and then development testing and site testing. Yeah.
All right. Thank you guys. That was a very profound answer, Paul and Brandon. Thank you for your contribution.
thank you for participating, Ivana. Okay, okay, let's move on to the next one. Ah, guys, it's 10 o'clock. Should we finish up after break? What do you guys think?
Let's leave that up to them.
Straight up.
If you guys don't respond, then we're just going to continue.
Let's just
Yeah, I
finish it
think we
off.
should continue and then take our break, maybe half 10.
Yeah, because we're almost done. I think there's three questions left, and
Yeah,
then
and also, I don't know if this will be okay with you guys, but Miss Linda requested that we do the summative today as well. But she did say that we can continue tomorrow. But I remember last time, not everyone was happy with both being done on the same day. So from the rest of the class, you guys should let us know if we should do the summative today or tomorrow.
yeah,
And I'm
guys.
not asking the people who waffle the whole time. I'm asking the rest of the class.
Guys, I am thinking we can finish the summative today. I mean, it's not that long.
Yeah,
Yeah,
it's very
What do you
short.
guys think? Yeah, and we're almost done with the formative also, man. So let's just try to get things done quicker.
Okay.
yeah, guys. Yeah, and then maybe tomorrow we can all just do touch-ups on our stuff and those who have
Yeah, I
started.
think she'll give us time to work on our assessments tomorrow,
Yeah,
hopefully.
get a breather.
But wait, what was the actual plan from Miss Linda? Was today only supposed to be Paul facilitating the formative, and then tomorrow it was supposed to be Brandon?
No,
It's supposed to be both
she,
formative and summative.
yeah, both today,
Oh,
yeah. But
yeah, okay.
she did say like if we run out of time today, we can continue tomorrow. But it's so short anyways, we might as well do it all today.
Yeah,
Okay, who's the last one, guys? There were three of y'all.
it was Taryn, but we'll do. She'll tag in with the summative, but
Laughing there.
very short. Taryn,
Guys,
are you fine with the tagging along on the summative?
Yeah, I'm fine with it.
I'm
Thank
sure
you.
you don't want to do everything by yourself there,
I
so
don't. So you guys have to.
Oh,
I'm not, and I'm sick. Okay, so Just bear with me.
Yeah, I figured you're a bit
Oh,
quiet today.
oh,
Yeah.
sorry, man. I just wanted to apologize for the question that I was answering. I was answering activity one, not activity two, so that is why the answers were a bit different. Forgive me. Sorry.
Oh, okay. No stress, no stress, eh?
Paul,
Yeah.
what's the submission date for these assessments, LP7?
It's on Monday, guys.
I
I'm kidding. I'm kidding.
Monday.
I'm joking, guys. Don't listen to me, hey. I think it's on.
Isn't it on the 3rd of October?
Yeah, yeah, yeah. It is. It's the following week, not next week, but the following week. But we'll confirm with Miss Linda, guys. Let's not take my dates, eh? Before I get in trouble here. Okay, let's finish up this quick. What's the next question, Brandon? Is it this one?
Yeah, this is the next question.
Okay, easy one, guys. Define system testing. SA2, I can see you already answering. Oh, Ivana wants to take it. Thanks, Ivana. Go for
Yeah,
it.
I'll let the ladies do this one.
Nice.
Yeah, you guys like to know think us ladies don't like to answer. Karen, let's show them.
Honestly,
Anyways, system testing is the process of testing a complete integrated system to evaluate its compliance with specified requirements. It involves verifying that the system meets its functional performance, design, and implementation requirements, as well as any non-functional functional requirements such as stability and throughput. System testing is a black box testing technique, meaning that it does not require knowledge of the internal design or code of the system. It rather focuses on testing the system as a whole, including its interactions with external systems, hardware, and users.
Thanks, Ivana. That was profound. You have exhausted the question. Profound, straight up for representing the ladies. Let's go to the next one. Mm, okay, the next one. Identify the general methodology approach to testing IT systems. Yeah. Anyone wants to give this one a go?
I'll take a shot at this one.
Thanks, Brendo.
Okay, so firstly, you would analyze your requirements. This means to identify and document what the system is intended to do by gathering and analyzing both functional and non-functional requirements. Next, you would plan your testing. This means to develop a detailed test plan outlining the scope, objectives, resources, timelines, and deliverables. This plan should specify the types of testing to be performed, criteria for success, and risk management strategies. Next, you would design the actual test. Create test cases and scripts based on the system and requirements. This involves crafting scenarios to test both expected and unexpected behaviors. The next step is to set up the test environment. Prepare the environment where testing will take place, including configuring hardware, software, and network settings. Next, you would execute the tests, run the test cases according to the plan, document the outcomes, and compare them to the expected results. Next, you would report any defects. This means to identify and document any issues or defects encountered during testing, providing detailed information to assist developers in resolving them. Uh, the next step, I think is the second last step, is to close the testing. After testing is complete, review the results, discuss what was learned, and ensure all documentation is finalized. This phase also involves evaluating the testing process and suggesting improvements. Then lastly, there's the post-deployment testing. Conduct additional tests after the system goes live, such as monitoring and performance checks to ensure it continues to perform as expected in the real world environment. Thank you.
Thanks, Brandon. That was profound, exhausted the question. Um, yeah, these questions are straightforward, so I don't think we need additions there. Let's move on to the second last one. Okay, explain the importance of collecting and recording data from tests. Who's taking this one for us?
Paul.
Oh, Tapelo. Cool. Go for it.
So I have 5 importances. Number 1 is foundation for analysis. The systematic collection and recording of data from tests serve as a cornerstone for subsequent analysis and evaluation. Comprehensive data acquisition provides a robust foundation for addressing efficiency of software or system under scrutiny. By meticulously documenting results, stakeholders can discern patterns, anomalies, and trends that may not be immediately evident. This empirical evidence forms the basis of informed decision-making, ensuring that subsequent actions are grounded in quantifiable insights rather than conjecture. Number 2 is enhancing the traceability. Recording test data is pivotal for enhancing traceability throughout software development cycle. It establishes a clear lineage between requirements, test cases, and outcomes, facilitating the identification of which tests correspond to specific functionalities. Number 3, facilitating communication. Documentation of test data plays a crucial role in facilitating effective communication among stakeholders. A clear and concise records allow for seamless dissemination of findings various parties, including developers, project managers, and quality assurance teams. Number 4, I have supporting continuous improvement. Collecting and recording data is instrumental in supporting continuous improvement initiatives within software development processes. By analyzing historical test data, organizations can identify recurring issues and areas for enhancement. And then the last one is ensuring accountability and governance. The meticulously recording of test data is essential for ensuring accountability and governance within test processes. Well-documented results provide a verifiable trail that can be referenced in audit or assessments, demonstrating due diligence in quality assurance efforts. This level of accountability not only bolsters stakeholders' confidence, but also mitigates risk associated within software failures and defects. Yeah, away.
Nice, Tapelo. You're on a roll today, hey? I see you. Impressing the ladies. Yeah. Okay. Let's move on. Okay, last question, guys. Last question. I also have similar points that Tapelo mentioned there. So, if anyone has anything to add, you're welcome to add there. But I feel like we'll all have similar stuff there and they're different. Oh, Ivana, sorry. I see your hand is up.
No, I actually wanted to answer the last question in session 4. That's why my hand was up.
Okay, go for it, Ivana. I didn't even read the question yet, but okay. Describe how to prepare for system integration testing. Ivana, go for it.
Okay, so preparing for system integration testing involves number 1, establishing a testing hierarchy. So we start testing at the competent level and progress to the system level, ensuring that each component is ready before integrating it with others. Number 2, considering climate interactions. So plan your testing according to seasonal changes and climate conditions to ensure the system functions correctly in various environments. Number 3, preparing for the operating environment. So I need to account for phase setups, partial system completions, and temporary uses to minimize risks and disruptions. So I just added a couple of more things. I'm using my data. Thorough test documentation is crucial. So it includes planning documents, test designing documents, test execution documents, test result documents, as well as lastly, conclusions drawn from all my testings. Yeah, somebody can just, correct or add.
Nice, Ivana. Nice. You've been working there, I see. Went into detail. Nice, guys. Nice. This is profound. Anyone else has anything to add? Yeah, I think Ivana exhausted that question, and we all exhausted. So let's go take a break for 5 minutes.
5.
I'm kidding, guys. I'm kidding. Let's take a 30 minutes break. We'll be back at quarter to 11, 10:45, right?
Before we leave, I just wanted to ask, Vuyo sent a document that has assessor report. What are we actually supposed to do with that document? Are we supposed to copy it and paste it here, or what's happening?
I think that's for the summative where you have to swap out what they have for the assessment report with the one that you've sent instead.
Yeah, exactly.
Okay, thank you guys.
Cool, guys. Have a nice break there. Let's rest up, and then we'll meet up for the summative.
Is everyone back? Can we start with the summative or not? Yes, I believe.
We are back, my guy. We are back.
Okay, cool. Okay, let's get straight to it. So the first question is demonstrate knowledge of computer configurations and hardware. Who wants to give a go at this? Okay, Taryn, you may go.
I want to answer. I just want to ask if this is the same question that they are kind of asked in the formative, where they were asking about the configurations. Is it basically the same answer?
I think so, kind of, but I think in the formative it's split into two questions or something like that. But if you feel like it's a question that is like similar to one in the formative, then we could skip it if that's okay with everyone. Or if someone wants to give their answer though, then they can.
I can give the answer. I don't think we should skip it.
Okay, you can raise your hand or you can just start speaking. Either way is fine. This should go quick, guys. Let's not drag this on. Okay, I guess I'll give my answer. So the first thing I have is the central processing unit. Firstly, apologies if there's noise on my side. The neighbors are a bit rowdy. So firstly, I have the central processing unit. This is known as the brain of the computer. The CPU handles calculations and executes commands that control the computer's operations. Then next, I have the memory or the RAM. This means random access memory. This temporarily holds data that the CPU needs for quick access. The more RAM you have, more RAM enhances multitasking and performance in demanding applications. There are different types of RAM. You get DDR4, DDR5, blah, blah, blah. Older ones are DDR3 and DDR2. Um, then next I have storage. So a traditional storage device, like the hard drive, like a HDD has moving parts, whereas a more modern hard drive, the solid state drive, is faster and more reliable than hard drive than HDDs. SSDs have no moving parts, leading to quicker boot times and data access. Next, I have the graphic processing unit. Yeah, you were right there, and this question is literally the same as one in the formative, but I am halfway through anyways. Next, I have the graphics processing unit. The GPU is responsible for rendering images, videos, and animations. It's essential for tasks like gaming and video editing. Next, I have the motherboard. The motherboard is the primary circuit board that connects all other components. It includes slots for RAM, GPU, and other peripherals. Next, I have the power supply unit. This converts electricity from an outlet into a form usable by the computer's components. Then I have the cooling system. This keeps components like the CPU and GPU from overheating. And then lastly, nope, not lastly. Next, I have the case. This encloses and protects all of the computer's components. Cases vary in size and design depending on your need, basically. Next, I have peripheral devices. Yeah, I just have a few examples. Devices like keyboards, mice, monitors, and external devices that enhance the computer's functionality. Next, I have networking. This includes network interface cards for wired or wireless connections, and also routers and switches that, you know, in extension manage network traffic. Then there's also expansion cards. I think this is the last one. Some of the examples I have are additional components such as extra USB ports, sound cards, and RAID controllers that provide additional features or capabilities. If there's anyone else that has extra information, feel free to add. If not, then give your go ahead, and then we can just move on to the next question.
I think you killed it, Brandon. Exhausted. I also have similar answers, so I think we should move on.
Okay, cool. Guys, just inform me if you can hear the background noise. Um, because on my side it's quite loud, so
We can't
apologies for
hear
that.
you.
Yeah, all good, Maggie.
Okay,
Are you fine, man? I can't really hear anything.
okay, cool. So the next question is state the advantages and disadvantages of using a network computer compared to a standalone computer. Who is willing to give a go at that?
I can go, Brendan.
I'll go.
Okay, Tapelo.
So the advantages of using a network. Number one, I have resource sharing. Networks allow multiple users to share resources such as printers, scanners, and storage devices, reducing costs and increasing efficiency. And then number two, I have data centralization. Data can be stored centrally on servers, making it easier to back up and manage and facilitating collaboration among users. Number three, I have improved communication. Networking enables quick communication through email messaging, and video call conferencing, enhancing teamwork and productivity. Number four, I have access to internet. Network computers can share a single internet connection, providing cost-effective access for all users. And then the last one is enhanced security. Networks can implement centralized security measures such as firewalls and access controls to protect sensitive data more effectively than standalone systems. Now I have the disadvantages of using a network. Number one, it's called complexity. Now, setting up and maintaining a network requires technical expertise, which can complicate management compared to standalone systems. Number two, I have cost. Initial setup costs for networking, hardware and software, as well as ongoing maintenance can be higher than using standalone computers. Number three, security risks. Networks are vulnerable to cyber attacks such as hacking and malware, which can compromise sensitive data if not properly secured. Number four, dependency on central server. If the central server goes down, it can disrupt access to shared resources and data for all users on the network. Now, the last one is performance issues. Network congestion and bandwidth limitation can lead to slower performance, especially when multiple users access resources simultaneously. Away.
Okay, thank you, Tapelo. Does anyone else want to add to that, or can we move on?
I struggled a bit in terms of understanding the question actually.
What is it that you're not understanding?
What's being compared to what here?
So, a network computer in comparison to a standalone computer. So remember the two types of computers that you have, the standalone being the one that's not
Yeah, that's
connected
the
to any
keyword I was
place.
looking for, network computer,
Yeah,
not
yeah.
just network.
Yeah, no. Just add that to your thing
It
if you
just
want.
changes everything if you just
Yeah.
leave it as it
I
is.
don't
And
know. I don't know why they ask the questions and they like don't check the questions, because it doesn't make sense. Like a lot of the time the questions don't make any sense.
because I also did it similar to the way Tapelo did it, and I feel like it's incorrect.
No,
Yeah,
it's
The context that we phrase it to a network computer
yeah.
instead.
I think with the way I answered it, there should have been a comparison. For example, if you're saying a network has
Yeah, if you
set
Google network
advantages.
computer and standalone computer, you'll get a different response from what you type in. I'm definitely sure about that.
So maybe there should be a comparison when you are stating the advantages and the disadvantages. If you say
So
a network can do this, a standalone computer cannot do this, in contrast to a
yeah.
network computer.
Yeah.
So are you guys saying that you're gonna state both advantages and disadvantages of the standalone computer and the network computer?
Mm-hmm.
I feel like this question just asks for the advantages and disadvantage of like the standalone computer. if I'm mistaken.
It does,
But
ne? But the
yeah, it does. It's
disadvantages,
just the way they ask the question is it's very off, you know. Like they should have just said advantages and disadvantages of standalone computer instead of saying compare it to this, you know. But
I,
yeah, I think Brandon, you can add those to like that list. We need to ask Mr. X and Miss Linda.
Okay, let me just quickly make note of it. Also, the register I put in the chat now, and it is also in the WhatsApp group, if I'm not mistaken. So you guys can sign the register quickly, and then we can continue.
Thanks, Brandon.
Okay, moving on to the next question. Or are you gonna sign the register first?
I was just giving everyone a moment to sign the register quickly.
Okay, cool.
Okay, that should be enough time, I hope, for you guys.
Hey,
So
yo,
on,
Brandon, have you sent it on the chat?
it's in the chat here on Teams, and also if you can't find it here, it is in the WhatsApp, on the WhatsApp group, I think. So if you're unable to see it here on Teams, then it will be there. Does anyone else see it on Teams here, by the way?
I can see it on Teams.
Okay. Are we good to continue, or do you guys need more time? I'll take that as you guys are done. So the next question is demonstrate knowledge of single processor and multi-core processors. Okay. Um, just raise your hand, or if you see no one's raising their hand, just start speaking. Anyone, this is one of the more easy questions, guys. So yeah.
so how long should the answer be? Since this thing of not giving us marks, I'll give the answer.
It should just be go with your gut, you see.
Yeah, just basically exhaust the question until you can't anymore.
Yeah,
Explain what single processor and multiprocessor
you
are,
will you
and
will reach you will reach a certain point where you will like feel like now you've done enough. So
yeah.
go ahead, Tapelo.
Okay, no problem. So a single processor system has one central processing unit that handles all tasks and operations. The CPU executes instructions sequentially, making it suitable for basic computing tasks like word processing, web browsing, and light multitasking. Since it only processes one task at a time, single processor systems can become slower when dealing with multiple resource-heavy applications simultaneously. Multiple processor systems, a multiple processor system includes two or more CPUs that work together to execute tasks simultaneously. These systems are designed for high-performance computing environments where parallel processing is essential. Multi Multiprocessor systems are more efficient at handling complex and resource-intensive tasks such as scientific simulations, large databases, and 3D rendering. Multiple tasks can be executed at the same time across different processors. Yeah, so that's all I have.
I feel like we all have a similar answer with that one. If no one has anything to add, we will move on to the next question. Yeah, this is also a question that's kind of similar in to one in the formative, but I think it's separate questions in the formative. So distinguish between batch processing and interactive processing. Who wants to take this one? I feel like half of the class is like sleeping or something, like legit, just like they don't give a damn.
It's not that we don't give a damn, just
Why do you feel attacked, Darren?
No,
Huh?
I'm just saying. I'm just saying. No need to.
Noah. Okay, let me try get this one.
Go ahead.
Let me just look for this thing. Okay, batch processing. Data is processed in groups or batches. The batches are usually large and consist of similar types of data. Examples include processing bank statements, utility bills, credit card transactions. No user's input is required during this processing, and batch processing typically occurs during off-peak hours like evenings and weekends when demand on the system is lower. And then moving on to interactive processing, also referred to as transactional processing. Data is processed one transaction at a time. Each response or update must be completed before the next transaction can begin. Inputs are generally small and entered interactively by the user. Users enter data into the system when prompted, and lastly, users can only input data that the system allows, guiding the interactions. Yeah, that's all I have there.
Okay, thank you so much, Paul. You've exhausted that question, I believe. Let's move on to this next one. Uh, just for this question, I will like give my answer, and then if you guys want to add anything, then you can. Um, so firstly, under batch for processing, I have basically. So firstly, I found my answers in the learner guide to this because this like table or like explanation for this exact table is actually completely in the learner guide. So that's where I got my information for it. It's like listed, and then you kind of just have to like take it from there and like put it in the specific, like the correct like category basically. So under batch for processing, I have data is processed in batches. Simple enough. Again, still under batch, in the response time section, I have batch processing usually takes place during the evening or the weekend when there is less demand on the processor. The main problem with batch processing is the delay in receiving the output from the data input. And then the last category is user interface. No user interaction is required with batch processing. Okay. And then for the next one, under interactive for processing, data is processed one transaction at a time. Response time, any response or update must be completed before the next transaction can take place. And then the last section, under user interface, data inputs tend to be small and input interactively by the user. The user inputs data into the system when prompted to do so. Their actions are limited to what the system allows them to enter. And then the last one, real time. So under processing for real time, data is processed within a given maximum time limit, usually under 4 seconds. And then with the response time, the time limit will depend on a number of factors. This includes the user requirements, type of processing, and amount to process. Then also it is normally assumed that the data will be processed as soon as it is received. And then I have my user interface requirement section open because I couldn't, like my understanding is that there's no user interface actually required for that section. I don't know if you guys understood this question like differently from what I did. So if you guys have any inputs, then please feel free to speak.
I kind of have the same kind of similar answer as yours. So yeah, I think you've exhausted it there.
Do you have anything under user interface for real time?
User interface for real time. I have highly responsive, must support continuous interaction and feedback. That's all I have.
Okay, I'm just gonna. Is it okay if I make a note of that?
Yeah, no stress,
Still
man.
your answers.
Can you can you just repeat that, Paul?
I said highly responsive, and then must support continuous interaction and feedback.
Brandon,
Okay, thank you, man. Is there anyone else who has anything to add?
Brandon, I have a question.
Mine says the last one, ne?
For real time, yeah.
Real time. It's the user interfaces for real-time systems are often highly specialized, requiring immediate updates and alerts. They must display information quickly and allow users to make decisions based on real-time data.
Okay, I feel like that is quite similar to
Similar,
Paul's,
just
but
a
it's
bit
just
different.
different. Yeah, just worded differently. Tapelo, you had a question?
Yeah, my question was to fill this table, did you find your information on the internet or in the learner guide?
This specific table, I found all my information on the learner guide. Like there's like a section where it lists all of the information, like word for word, that you would need to copy into the table. The only thing I didn't find was for that last, or like maybe I didn't like read it, understand it correctly. But the point is, all of the information I found in the learner guide. So yeah,
I have a question as well.
yeah.
So,
Go ahead.
if you can find the real-time user interface requirements in the learner guide, then where did Setu and Paul find the
I
answer?
used both the learner guide and the internet.
Okay,
I
noted.
also did find it on the learner guide as
Yeah,
well.
I also did
I
the
used the
same.
internet for additional information as well. It's kind of
Okay.
similar to what Brandon wrote, but just a bit more descriptive.
Okay.
Yeah, I also did the same, and yeah, I use both learner guide and internet.
Okay, no, that's cool. Then my thinking was also with this question, there is specifically, it's such a low mark, 3 marks for this whole table. So I thought like the information that they have in the learner guide should be sufficient enough, even if it's like short, you say. So, but I feel like we all got some clarity on this question now, and we can probably move on to the next one. Yeah, guys, don't forget to remove this table and copy in one video, the one video sent into the WhatsApp group, guys. Um, yeah. So the next question is: describe the operation and implementation of components of a computer. Okay, who's willing to give that a go? Can we have some new people here speaking here, guys? As a Bliffman. Droog. Guys, the usual suspects. Do you guys have anything?
Okay, I'll give what I have here.
Okay, thank you, man.
So, number one, I have the central processing unit operation. The CPU is the core component responsible for executing instructions in a computer system. It operates by fetching instructions from memory, decoding them to understand the task, and executing the necessary operations, and storing the results back into the memory. The CPU continuously repeats this cycle, called the fetch, decode, execute cycle, to process tasks. Modern CPUs use techniques like pipelining, where multiple instructions are processed in different stages simultaneously, and multi-core processors, which allow for parallel execution of tasks, significantly improving efficiency. Number two, I have memory management. Memory management is essential for a computer's smooth operation. The system's random access memory temporarily stores data and instructions needed by the CPU for immediate processing. The operation system manages memory allocation to different programs, ensuring that active applications get enough memory while optimizing the overall system performance. Virtual memory extends RAM's capacity by using part of the hard drive as temporary storage, allowing the computer to handle more tasks even when the physical RAM is insufficient. Next, I have input and output operations. Input and output operations are essential in enabling user interactions with the computer. Input devices like keyboards and mice allow users to send commands, while output devices like monitors and printers display or provide the results of these commands. The I/O system manages data flow between the CPU, memory, and peripherals. It uses device drivers, specialized programs that communicate with hardware devices to ensure that input and output operations are efficiently coordinated and processed. Next, I have the operating system. Operating system is crucial in managing the computer's hardware and software resources. It acts as a bridge between the hardware and applications, managing tasks like memory allocation, file handling, and process scheduling. The OS ensures that applications receive sufficient resources while keeping track of the user's interactions and system performance. Common operating systems like Windows, Mac OS, and Linux are designed with a user-friendly interface that allows users to easily interact with the hardware and run applications as well as manage files. And the last one is network and security integration. In modern implementations, computers are often integrated into networks, allowing them to communicate and share resources such as files, printers, and internet access. Networking protocols like TCP or IP handle the data transmission across different systems, ensuring that information is delivered correctly and securely. Security measures such as firewalls, antivirus softwares, and encryption are implemented to protect the computer from unauthorized access and cyber threats. A well-implemented computer system combines network and security features to provide reliable and safe operations across local or wide area networks.
Thank you, Tapelo. I feel like your answers like exhausted the question. I myself probably need to add a section on software, so I will make a note of that because I have nothing about the OS and all of that. Let's move on to the next question. Explain the concept of firmware and what are the advantages of firmware. Is there anyone who wants to take this one?
Can I go with this one?
Cool.
All right, chap.
Gold spot. Can't do gold spot. Listen to your mouth.
So, oh, sorry about that, guys. Firmware refers to a type of software that is embedded into hardware devices to control and manage their functions. It provides low-level control for the device's specific hardware and is stored in non-volatile memory, such as the ROM, which is read-only memory or flash memory. Unlike regular software, which can be easily updated, firmware updates are more complex and are used to enhance performance, fix bugs, or add new features. And the advantages, I think I have less than 5. So the first one I have, it's efficiency. In terms of efficiency, firmware is typically optimized for the hardware it controls, leading to faster performance and lower resource usage compared to general purpose software. And in terms of stability, since firmware rather is embedded in the hardware, it is less prone to corruption and can provide a stable operating environment for devices. And in terms of next, it's direct control. Firmware operates close to the hardware level, allowing it to manage devices' functions and settings that software applications may not directly control. Then lastly, I have on enhanced security. Firmware can implement security measures at a low level, helping to protect against vulnerabilities that could affect the entire device. Thank you.
Thank you, Setu. May you please just list again the
Advantages.
Yeah. You don't have to read the whole sections.
Okay, it's efficiency.
Okay.
Firmware. Number 1 is efficiency. The second one is stability. Then third one, it's direct control. And lastly, it's enhanced security.
Okay, thank you for that. I have a few extras.
Extras, okay, now.
Yeah.
Man.
Maybe it's similar, it's just worded differently, but let me go over mine. So firstly, I have hardware management. Firmware controls the fundamental operations of the hardware, such as managing how a computer's motherboard interacts with peripherals or how a smartphone's camera processes photos. Then you said you had stability already, right? I will skip that one. Then I have flexibility. By swapping out the PROM component, we can expand the range of machine instructions, such as adding vector multiplication as a built-in operation. Did you have anything on lower hardware costs or like lower costs?
Oh, I have nothing on costs actually.
Okay, so lower hardware costs. Simpler instructions are easier to hardwire, which reduces the overall costs of the hardware. Um, you had a section on efficiency, right?
Yeah.
Okay. Then I think you don't have this one. Customization. Firmware can be specifically designed for the hardware it controls, allowing for customized features and enhanced capabilities. You had something on security, right?
Mm-hmm.
Okay. Then I think these last two you didn't have. Durability. Firmware is designed to be robust and reliable over time, which is important for devices used in tough conditions. And I'm not sure if you had integration, but I'll say it anyways. Firmware ensures smooth operation between different hardware components, contributing to a unified user experience. I feel like both our answers combined probably exhaust that question quite thoroughly. So we'll just move on to the next one. This is an easy question. I don't want the usual subjects for this one. List the parts of a computer. Guys, give me something. Sandile.
This is the part where you select them, yeah.
Anyone, man, guys, man.
Hey,
Ricardo,
guys.
like, speak up, man, guys. Like, really. Yo.
Sure, guys. Hey, I'm back, man. I had an emergency there.
Go back to your emergency. We don't need you.
Oh, I see the question.
So, Kayla, you can take this one if your stuff is open already.
Nah.
It's not open.
I want to.
Okay, Darren can go to have a go at this one. So list the parts of a computer, please, Darren.
I'm hoping that mine is CPU, RAM, storage hard drive, and SSD, which is under storage, motherboard, PSU, input devices, output devices, GPU, cooling system, case. That's what I have.
Yeah, simple as that, guys. Easy money. So we can move on to the next question. I don't think she missed anything important. If you guys feel like she did, then you can speak up, but I doubt it. Next question. Samkele, describe and explain the functions of any three named components of the computer. I feel like you can just, like, with this question, you probably choose whatever three you want to speak about. So just give us your answer, please.
Any three, né?
Yeah.
Like CPU, RAM, and hard
Yeah.
drive.
Yeah.
Okay. So CPU deals with processing information. Usually from the hard drive or input devices, and then hard drive usually is used for storing information permanently, and then RAM, it stores temporarily information, and then if it restarts, the information also gets reset. That's just an overall. If someone has a more detailed answer, they can go.
What components did you have now?
CPU, hard
CPU,
drive,
hard drive.
and RAM.
Okay, if there's anyone who has different components, you guys can, like, bring them up, please. Just like a few more, like one or two more. Or do we all have the same stuff? Because I also have a CPU. Did you have a RAM, right, Samkele?
Yes, I also had RAM.
Okay. I have one different. So I have the graphics processing unit. This specializes in processing and rendering graphics, handling tasks related to visual output like images and video. This makes the GPU crucial for high-performance tasks such as gaming, video editing, and 3D graphics, enhancing the quality and speed of visual applications. I don't think anyone is willing to add to this, so we can probably move on. Okay, so the next question, briefly describe the following. So firstly, we have data handling and memory operations. The next we have control flow operations, and then arithmetic and logic operations. So who wants to give a go at this one?
Okay, it says briefly, ne? I don't have to do
Yeah,
essay.
so that cuts out you. You can't answer this one.
Nah, it's not an this time around. Don't worry.
Okay, I'll go ahead, man.
Okay, should I describe one or three?
Depending on how long your answers are, you can probably do all three. If it's not too long.
Give us the essay.
Yeah.
Nah, chance. Okay, data handling refers to the processes involved in collecting, storing, managing, and manipulating data. This includes operations such as reading data from input devices, writing data storage, and retrieving data for processing. Memory operations involve the management of data in a computer's memory, including the allocation and deallocation of memory for variables, as well as accessing data stored in different memory locations, such as RAM and cache. Efficient data handling and memory operations are crucial for optimizing performance and ensuring that applications run smoothly. Then for control flow operations rather, these determine the order in which these instructions are executed in a program. The operations enable a program to make decisions, repeat actions, and branch to different parts of the code based on certain conditions. Common control flow operations include conditional statements such as if-else statements, loops such as for and while loops, and switches. By controlling the flow of execution, programmers can execute a dynamic can actually create a dynamic and responsive application that can help handle various scenarios based on user input or other factors. Then the last one, arithmetic and logic operations. Arithmetic operations are mathematical calculations performed on numerical data such as addition, subtraction, multiplication, and division. These operations are fundamental in programming for tasks that require numerical computations. Logic operations involve manipulating Boolean values, which are true or false, and are used to make decisions in programs. Common logic operations include AND, OR, and NOT. These operations are essential for evaluating conditions and controlling the flow of program based on logical expressions. Together, arithmetic and logic operations enable complex calculations and decision-making processes in software applications. Thank you.
Okay, cool. Your answer pretty much like goes through that question quite well. I have similar stuff. If anyone else has anything else, like anything different, they can speak up. If not, I will move on. The next question: briefly describe the complex instruction set computer, pros and cons. So, guys, you can just go ahead. Anyone?
So basically the advantages and disadvantages, right?
Yes.
Okay. Anyone can answer, just like me.
Oh, so you weren't, yeah, is it?
No.
I will answer, I guess. So the
Sharon
first,
jumped on that as if she was about to give.
yeah, I immediately
Just
started sitting back in
clarifying.
my chair. I started sitting back in my chair thinking, okay,
No,
she's gonna like,
you on board.
yeah, I will answer rather. So firstly, I will list the pros. So the rich instruction set. Is that the first pro? Yeah. CISC processes feature a broad range of instructions allowing complex operations to be executed with fewer instructions. This can result in more compact code. Next, I have efficient code size. The ability to perform multiple operations with single instructions helps reduce code size, which is beneficial in memory-limited environments. Next, I have the ease of programming. High-level operations can be implemented with less assembly code, simplifying programming tasks. Next, I have microprogramming. Implementing new instructions through microprogramming is cost-effective and simpler compared to hardwiring, and it supports backward compatibility by allowing new computers to run older programs. Next, I have memory efficiency. As instructions become more capable, fewer instructions are needed to accomplish a task, making more efficient use of relatively slow main memory. Next, I have compiler simplification. Microprogram instruction sets can align with high-level language constructs, reducing the complexity of compilers. Next, I will list the cons. Increased hardware complexity. The need to support a wide range of instructions makes the processor design more complex and can lead to larger, more complex hardware. Next, I have variable execution time. Instructions can vary in length and execution time, which can complicate pipelining and potentially slow down overall performance. Next, I have underused instructions. Many specialized instructions are infrequently used, meaning that a significant portion of the instruction set may be redundant. Then I have condition code management. CISC instructions often set condition codes that as side effects, which can lead to additional overhead and require careful management by programmers. Lastly, I have complexity across generations. Each new processor generation tends to include a subset of instructions from earlier versions, leading to increased complexity in both instruction sets and chip hardware. If anyone has anything else to add, you may speak up. Tololo. Okay, we can move on then.
It's fine, man. You exhausted the question. Let's just move on.
Okay, next question. What is the purpose of testing? I'm going to skip this one, guys, because I believe there's questions in the formative that is similar to this one, if I'm not mistaken. Unless someone feels like talking anyways, so...
I feel like it's the same, man. I feel like we've covered this one. Yeah.
Okay, move on. Identify factors which affect testing. Who wants to give a go at this one? Feel free to just unmute and start speaking if you want. Paul, are you taking this one or what?
I'm just scrolling down to check what I have, but I can take it. I've got an essay here. Okay, factors affecting testing effort. The first one, project documentation. Throughout documentation is beneficial. The need for detailed test cases can lead to delays. Maintaining extensive documentation during test execution demands significant effort, especially when managing fragile test data and requirements, frequent updates and restoration. Then I have product size. As the size of the product increases, so does the complexity of the project and the project team. Larger teams and projects make it harder to predict and manage progress, contributing to higher likelihood of failure in big projects. And then the next one I have is lifecycle module. The chosen lifecycle module impacts testing. The V model is more sensitive to late changes, while incremental models tend to incur higher costs for regression and testing. Then I have process maturity. The maturity of the process is in place, including test processes play a crucial role. Mature processes that effectively manage changes throughout the project can help reduce testing costs. And then I have time pressure. While time constraints shouldn't justify unnecessary risks, they necessitate careful decision making and smart planning throughout the testing process. And then I have people factors, the skills of the team members, and how well those skills align with the project requirements are critical. A skilled team can often overcome challenges that arise during the project. And I have team dynamics. solid relationships, and commitment to shared goals and vital for effective teamwork. In testing, collaboration with those outside the team is essential, making stable team dynamics important for success. Then lastly, quality of test results. The quality of the software at the start of the testing and the speed of fixing defects significantly impacts testing efforts. Effective detects resolution prevents delays in the testing process, avoiding the need repetitive cycle to fix the resets. Yeah, that's all I have. Anyone else have something to add or something different?
Yeah, Seto, I see you're already unmuted.
Am I?
Always ready to chime in. You don't even know it.
Yeah, he has his pages of essays there.
He's gonna one up you now. That man wrote the thesis.
Yo, a whole Bible dictionary.
There's some similar stuff, but I think mine is just worded differently.
Okay.
Should I just go on?
Do you want to give your answers or should we move on to the next question?
Okay, on the first one, I have test environment. The setup in which the testing occurs can affect the results. This includes the hardware, software, network conditions, and configurations that may differ from the product environment. Secondly, I have test design. The quality of test cases, including their comprehensiveness and relevance, impacts the ability to uncover issues. Poorly designed tests may miss critical defects. The next one I have testing tools. The tools and the technology used for testing can affect efficiency and the ability to automate tests, which can lead to more accurate and faster results. Next up, I have test data. The quality and relevance of the data used during testing are crucial. Inadequate or inappropriate test data can lead to misleading test results. Then next up, I have team expertise, which I think he mentioned also. The knowledge and experience of the testing team play a significant role. Skilled testers are more likely to identify issues and conduct thorough testing. Next up, I have time constraints. Limited time for testing can lead to rushed processes, increasing the likelihood of overlooking defects. And second, lastly, I have requirements clarity. Clear and detailed requirements are essential for effective testing. Ambiguities can lead to misunderstandings and inadequate test coverage. Then lastly, I have changes in scope. Frequent changes in project scope or requirements can disrupt testing efforts and require adjustments to test plans and cases. Yeah, that's that.
Okay, thank you, man. My answers are quite similar to yours and Paul's, so thank you guys for that. I don't think there's anything else we can really add. Moving on to the next question. Describe briefly a test approach or methodology. These are one of the questions I read marked because I can't even remember why. Are we supposed to like choose any test approach or is there a specific one we were supposed to mention here? Like what do you guys have? Anyone?
So I started off by defining test approach or methodology, and then basically I chose an approach.
Is it in the learner guide? Or the test approaches in the learner guide? I'm asking.
That's the thing. In the learner guide, there is one.
V model. Which one is
So
there?
then just choose that one.
Okay. I wrote it as my answer, but I still marked like this answer, or like this question as one that I am not certain on. I will tell you guys my answer, and you guys will probably pick up why I feel like it might not be correct or why it doesn't fit. So firstly, they don't have a specific name for the approach. That's the first issue with it. It just starts giving you steps, basically. So what I have here, the approach includes the following steps. First, from the start, it doesn't sound right. Conduct testing of all critical business. Sorry, guys, I have a phone call coming through. Just give me a second.
Would anyone else like to add?
Let's just wait for him to finish off his response, and then we'll just compare.
Yeah. Okay.
Yeah, sorry about that, guys. So, step one, conduct testing of all critical business functions at least once for both minor and major upgrades. Already sounds wrong to me. Two, verify that the key contact list or lead matrix is current. Three, examine the reports needed for tracking system testing. By the way, uh, I think I found this answer under a specific section where they talk about almost like the general testing approach that you would use. So like I feel like the way they listed it in the learner guide is for that specific example. Like you see in the learner guide, they will have a business as an example, for example, like, and then they will apply, like they will tell you, oh, this approach for that specific scenario. Whereas when you give your answer in the assessment, you're supposed to like turn that into a generalized like answer almost.
Yo,
And then you,
Brandon.
yeah.
So I feel like your answer's on the right track because my first one also have testing critical functions, and then my next one is update contact list.
Where did
And
you
then
find your answers?
basically, I also use the learner guide and internet sources. Then I compared them together. Then I put like blended the answer together. You know.
Okay, then I feel like it's best that you give your answer here. So
Okay, cool, cool, cool. Okay, the first one is testing critical functions. Both mirrors and major upgrades will include tests for all critical business functions at least once. And then next one, update contact list. Ensure that the key contact list lead matrix is current. Then the third one, review tracking reports. Assess the reports needed for the monitoring system testing and update them as necessary. Then review issue management process, evaluate the issue management process and make updates if required. And then confirm test plans, verify the test conditions, cycles, and plan align with functional requirements, including conditions for testing, user security access, and then group test conditions. Organize the test conditions by business process. They should be a comprehensive test plan that tracks transactions throughout the entire system rather than at the entry of exit points and at the end of the test plan. Then I have update interface listing. Ensure the ensure the interface listing worksheet is up to date. This worksheet details all external interfaces, including files sent or received outside of HRMS and SA, as well as all the database linked and accesses permissions.